Alright guys, welcome back again. Let's give a shout out to someone from period 8. I feel bad, I've been neglecting you the first couple of videos. So again, just so I don't forget who I've talked to, let's give a shout out to Sage, Rishi, Zaber, and Pia. And this is a very important lesson. I hope everyone is watching this, but why aren't you? Because you should be watching every video. Today we're going to talk about the unit circle. Now, the key about the unit circle is that the radius is 1. That's what defines it as a unit circle. Okay, so whenever you're dealing with something where the radius isn't 1, it's not the unit circle anymore. The reason why we have the unit circle defined is that we can get trig ratios from these angles that are always the case. So, based on the unit circle, we will be able to know what the cosine of 45 is right off the top of our head, what the sine of 45 is, what the sine of 30, cosine 30, and so on and so forth at those special reference angles. But let's look at a unit circle. First, let's draw in a triangle on our circle here. And this is theta. That's the angle. The radius is 1. There's the point x comma y, which means that the x direction in the x direction you move x units, and in the y direction you move y units. So that is our setup, which gives us the few things. If you look at this, the cosine of theta is x over r. The sine of theta is y over r, just from trigonometry. Remember SOHCAHTOA. And then finally, tangent is going to be y over x. Now, since r is equal to 1, though, we can define that x is just equal to cosine theta and y is equal to sine theta, which means that for tangent will be sine over cosine. Okay? So, with our unit circle, so this is actually any circle right here. With the unit circle, the triangle becomes this. Here's 1, here's theta. We call this the cosine, and we call this the sine. So the length up is sine, the length across is cosine. You have to think of cosine as x, sine as y. Now, here's how we get these values. And they come back from our special right triangles. Do you guys remember those? I'm sure you do. I'm sure all of you are smiling, thinking back to the day when you were working with 45, 45, 90 triangles and 30, 60, 90 triangles. Hopefully this rings a bell to you. The reference of 45 degrees. Now, your teacher could have given you many different patterns for this, but just generically, one of the patterns is x, x, or side, side, and then side times root 2. Hopefully that rings a bell for you guys. However, for a 45 degree on our unit circle, we want the radius to be 1. Well, what do I have to divide that by to get 1? I have to divide it by itself. So if I divide this by x root 2, I divide this by x root 2, and I divide everything by x root 2 to get it to a unit circle, I get 1. This becomes 1 over root 2, but we can't leave it like that. So if you rationalize, you get root 2 over 2. So this side is root 2 over 2 and root 2 over 2. So what that is telling us is that on the unit circle, or just in general, the cosine of the angle 45 is root 2 over 2. The sine of 45 is also root 2 over 2, which makes sense because they should both be the same. So if I drew this 45 degree reference angle, and I make my triangle, what that's telling me is at 45 degrees, the point xy is root 2 over 2. It's root 2 over 2 in the x direction, and root 2 over 2 in the y direction, up. And again, that makes sense because this distance and this distance should be the same for a 45, 45, 90. Well, we can do that for all of these reference angles of 45. Here's the next one. Well, guess what? The values are the same except for the signs. If I'm moving over to quadrant 2, my x's have now gone negative. So the point becomes negative root 2 over 2. And we're still in the positive y direction, so we keep that at 2 over 2, root 2 over 2. Alright, so that's another 45. If I have a reference of 45 here, and this is also the angle of, what is that, 225, if I was going from 0. Again, the length is root 2 over 2 and root 2 over 2. And in quadrant 3, they're both negative. Because x is negative, we're going in the negative x direction. And the y is now negative. So that is the point, that's a negative sign right there, that is the point at a reference angle of 45 in the third quadrant. But again, here's the thing. All you guys have to remember is for 45-degree angle, they're both root 2 over 2. So you have to remember the number root 2 over 2. That's all I'm really asking you to remember. Because you don't have to memorize this whole circle, because you should know what's negative and what's positive based on where it is. So again, we have root 2 over 2, root 2 over 2, and then we look and see, okay, which ones are negative here? I'm now back in the positive x direction, but the sign is still negative, or the y. We're going down from the origin. So those are my 4 values for the different reference angles of 45 degrees. We'll be getting, again, I understand this is the first time you've seen them, you won't get them right away, but it's important to remember the number root 2 over 2. Now, there's 2 other numbers we have to remember based on this reference angle and the other one as well. 30s and 60s are very similar, they're just flipped around. So if the reference is 30, let's divide everything by 2x to get a radius of 1. And what happens is you get these go away, so you're left with that, and these go away. So what happens is for a unit circle with a radius of 1, the side across from the 60, or the cosine, is root 3 over 2, and the side across from the 30 is 1/2. Okay? Now, here's the way to remember it, I think. I like to look at it visually. I draw a 30-degree angle, and I draw this triangle. Let's pretend this is 30. Which side is longer, the x or the y? Clearly you should see that it's the x. So the x value will be the root 3 over 2, and the y value will be 1/2. These are the other 2 numbers you have to remember, root 3 over 2 and 1/2. So all I'm really asking you to do is remember root 2 over 2, root 3 over 2, and 1/2. The root 2 over 2's go together, and for 30s and 60s, there's either a root 3 over 2 or a 1/2. One of each. You have to figure out which one's which. So if I go over here and have a 30-degree angle, here I have a 30-degree angle, and here I have a 30-degree angle, I can write the rest of my points. Okay, and they're always going to be the same. So for any reference of a 30-degree angle, the x is longer than the y. Same thing here, the x or the cosine is longer than the y. So again, these are all going to be root 3 over 2 comma 1/2. You just have to figure out what the sign is. So here, it's negative root 3 over 2, positive 1/2. Here, it's down and to the left, so they're both negative. Here, we have root 3 over 2 is again positive, but then we have a negative 1/2. Okay? So the nice thing is the 60s are basically the same thing as the 30s, but the x and the y switch. So when I divide everything by 2x to get a radius of 1, you get the same values. You get a 1/2 and a root 3 over 2. However, it just switches them where they are. So if I draw a 60-degree reference angle and a triangle, look at how long the x is. It's the shorter piece. The y is the longer piece. So that means the shorter piece is 1/2. The longer piece is root 3 over 2. Now we are just switching them. If I have a reference angle of 60 over here, oh, that's a terrible line. Alright, so let's just draw a couple of reference angles of 60. And when I say reference, remember, that's like this angle is 60, this angle is 60, this angle is 60, and so is this one. And we can, again, fill out our points. We know that at 60, it's the x is the smaller piece, the y is the bigger piece. So the x is negative also in that case. In quadrant 3, we have negative x and negative y. And in quadrant 4, we have a positive x and a negative y. So those are the values at each reference of 60. Now, you'll get better at knowing, like when I say a reference of 60 down here, you'll get good at knowing that that's 240 degrees because you have a full 180 to go half a circle plus another 60. So at 240, that's a reference of 60, you're at that point. Okay, so again, key thing from this, those values you need to remember. Negative 1/2, or not negatives, ignore the negatives for now. Just remember the numbers 1/2 and root 3 over 2. One in each, and then the other 45-degree angles are root 2's over 2's. So So sketch each angle, state the reference, and label the coordinates of the endpoint of the terminal side. Again, these are unit circles for these problems. So 225. Well, here's 180 goes all the way to here, and then 225 is right here. To find the reference angle, just subtract 225 minus 180 if you need to. So this is 225. Well, the reference angle is equal to 45 degrees. The 45 degrees, if this is 45, we remember from our last page that the x and the y are the same. And the value we use when they're the same are root 2 over 2's. You just need to remember that. Yes, I know it's memorizing, but it'll help you going forward with everything else. And then the last step is, what are the signs here? You have to think about that. I'm negative x and negative y, so my coordinates are actually negative root 2 over 2 and negative root 2 over 2. So and that's all I really needed. That's all I have. I have sketch, I stated the reference angle, I stated the coordinate. Now let's do negative 150. First of all, negative 150 goes backwards. So negative 180 is here. So negative 150 goes about here. Well, if I'm going 150, how much more does it take to get to 180? You should figure out that the reference angle is 30 degrees. Okay? Now, I'm not even going to look back at my other side. I know a 30 or a 60 involves 1/2 and root 3 over 2's. And then I just look at the shape. I drew this in the correct spot. I mean pretty relatively. So, what looks longer? Does my x look longer or my y? Hopefully you guys state that the x side or the cosine looks longer here. So for 30 degrees, the x is bigger and the y is the smaller one. And then I go, okay, so I had to use root 3 over 2 for x and 1/2 for y. And I have a negative in the x and a negative in the y. And that's it. We're done. Alright, so I notice I don't have any radians on here. We'll do some radians in class. Remind me if I forget. 135 goes to 90 and then here. Well, how much more is left? And this was negative 150, by the way, up there. Hopefully you guys see that you need another 45 degrees to get to the end. So that means our reference is 45 degrees. And again, a 45 degree has the same value for x and y. So this is going to be root 2 over 2, root 2 over 2. And the negative one is just the x. Okay? We're on our last one, negative 300. Again, negative means we're going around the wrong way. Well, I shouldn't say the wrong way. We're going around clockwise because it is negative. And you guys could pretty much figure out how much more do I need to go for a full circle. I need another 60. So that means that the reference angle is going to be a 60. So this is negative 300. In order to get a full circle, I need another 60. So that means my reference is 60. Well, let's look at that triangle. Now, at 60 degrees, the x piece looks shorter than the y piece. So that means that the point will have the 1/2 in the x piece and the root 3 over 2 as the y. They're both in quadrant 1, so that means they're both positive. And I didn't state it, but I did on the diagram. My reference angle is 60 degrees. And that is all we're doing. So all we added today was on a unit circle, you could tell me those coordinates at those angles by finding out the reference. So we kind of built on everything that we did the last couple days. So anyway, we'll practice more of these. We'll practice with radians, but that is it for the unit circle.